Okay, so today we are going to start this new chapter, light. So in this chapter, we will also study how to see things around us. How does the light helps us to see things around us? I mean, suppose you're right now you're sitting in front of your laptops or your mobile phones. How is that you're able to see the screen of the mobile phone or the screen of the laptop? What makes you see things around you? What makes you see colors around you? Okay?
Light.
Yeah, light. So how is that? How the light helps you, that is what we are going to study. Next, what we are going to touch upon is the reflection of light and how light gets reflected. Okay? So this is what we are going to learn. We are going to also touch upon the laws of reflection. Fine? So let me also quickly tell you, how does the light make things visible to you? Let's say this is sun and this is where you are standing. Your eyes are here. So you're trying to actually holding a pencil in your hand. So this is a pencil or a pen. Okay. So you're trying to see a pen in your hand. Now what happens is, from the sunlight goes everywhere. In all the directions you have the light rays which is going. So one light ray must be coming in your eyes directly from sun. So that is called as direct light ray, which is directly coming from the sun. There is another light ray from the sun. There is this light ray which is falling on the pencil, and the pencil reflects the light, and then the light comes to your eyes. Okay, now you may ask me, ma'am, from the pencil the light ray can get reflected in various other directions also. Yes, obviously, from the sun the light ray comes to the pencil, and pencil will be able to reflect the light ray in all the directions. One light ray will go here, one light ray will go towards the left, towards the bottom left, towards direct bottom, but there will be few light rays which will fall and come towards your eyes. So right now what is happening, you are receiving a light ray only after reflection from the pencil. So this light ray is called as reflected light ray. It is not the direct light which is coming from the sun, but this light ray is reflected by some other object. Maybe a pencil, maybe a plate that you're holding, maybe a glass of milk that you're holding, maybe the tree. When that reflected light ray enters your eyes, that's when you are able to see this pencil or anything that you're holding. Suppose, for example, sun is not there, so it is pitch dark. Will you be able to see this pencil then?
No, ma'am.
No. Why? Because there is no light which is falling on the pencil, and that light which is, see, for the pencil, this light ray, are you all able to see the cursor? This light ray, the one which is coming from the sun to the pencil, this is a direct light ray for the pencil. But when the pencil reflects the light ray, then this light ray becomes reflected light ray. So it is because of the reflected light ray that you're able to see all the things around you, everything around you. So if there is no sun, there is no reflected light ray, because pencil is not a luminous object. Luminous का क्या मतलब है? The object which has light of its own. Okay, this is a light. Suppose there is no sun. You're working in a very dark room. So what do? You switch on the bulb. So now once the bulb is switched on here, the bulb now becomes a luminous source. Okay, because bulb has light of its own. So this becomes a luminous source. So now what will happen? From the luminous source, one light ray will go and fall on this cell, and then the cell will be reflecting the light ray towards your eyes. The cell will also be reflecting the light ray in all the other directions, like this, like this, like this. But few light rays will come towards your eyes, and that's how you're able to see that there is a cell which is kept. Same happens here also. Suppose there is no bulb, so you use a torch. So now the torch becomes a luminous object. This next what we are going to talk about is reflection of light. Now we've studied that light gets reflected, but how the light is getting reflected, that is what we are going to study here. Now see, when the light falls on a polished or a shiny surface, it changes its direction. This is called as reflection of light. Let's say there is a source of light. What is a source of light? The torch is a source of light, isn't it? And if you flash this torch onto any object, any different material, like can be a CD, here he's taken a CD case. So even the CD cover is also a kind of a shiny surface. It's a polished surface. Any shiny surface will be able to change the direction of the light even faster. If it is a very shiny surface or if it is a very polished surface, so then the light will be able to change its direction faster. Suppose if you throw this, flash this torch light. Now this light is the incoming light. So suppose this is a plane. This is the surface on which you are flashing the light. So for this surface, what is the light which is incoming? This is the light which is incoming. So when this is the light which is incoming, the light will get reflected in this direction. This is called as incident light. Whichever light is going out after reflection, so this is the reflected light. So this is the incident light or incident ray. This is the reflected ray. If I draw a perpendicular line, it is an imaginary line but a perpendicular line. This black line is perpendicular to what? Mirror. Very good.
Sir,
Mirror. This black line is perpendicular to the mirror. This is the mirror. The blue one is the mirror. And please remember, this is an imaginary line. It is not a proper line. It is an imaginary line. So now the angle between this incident ray and the normal. So this angle between incident ray and the normal is called as angle of incidence. Similarly, the angle between the reflected ray and the normal is known as angle of reflection. So this is the reflection of light, and now we are going to discuss the law. So what I have done is, all those diagrams I have actually converted them into something like a ray diagram here. So look, this is the mirror. This is the mirror. This is called as the incident ray. You have to draw the arrows. You have to put the arrows properly. This arrow is outside. It is the reflected ray. This dotted line, the perpendicular line here that you see, is the normal. So incident ray, normal, reflected ray. And the angle between incident ray and the normal is called as angle of incidence. Similarly, the angle between normal and reflected ray is
angle of reflection.
Yes, is called as angle of reflection. And this point where all the three lines are meeting, this point where all the three lines means incident, normal and reflected ray are meeting, is the point of contact. That is the point of contact. So what is the first law? Angle of incidence is always equal to angle of reflection. So that is the first law. I will be equal to R. Now look at the second law. Second law statement I have written here. The incident ray, the reflected ray and the normal at the point of incidence all lie in the same plane. Point of incidence means point of contact. Means that is the point where all the lines are incident. All the lines are falling. So which is that point where all these three lines are falling? This is the point. Yeah, point of contact. This is the line. See, the incident ray is also going and falling, coming here. The normal is also touching here. The reflected ray is also going out from this point only. So that is the point of contact or the point of incidence. Okay, fine.
Yes, ma'am.
Now let's study about image formation by a plane mirror. Suppose if I keep a box here or a drum here, I will see the same image here. Okay, can you touch that image? No, because that image is somewhere behind the mirror. Okay, somewhere inside the mirror. So look at this. This is a mirror. The blue color, this line that I have shown here is the mirror. These red brush like structures that I have shown here, it shows that it is a painted surface. Okay, painted means you must have seen your mirrors. Just imagine the front surface of the mirror is polished. Polished means it's very shiny. So this is the front surface, this side is the front surface. Okay, this is the front surface. The back side is painted. The back side is painted. Okay, so when you stand in front of the mirror, you see your image exactly like how you are, but that image is formed behind the mirror, somewhere inside the mirror, behind the mirror. Okay, here. Now suppose if you move ahead, what do you see? What changes in the image will you see? The image will also be coming closer to the mirror. You walk close to the mirror, your image will also walk close to the mirror. Okay? When you go far from the mirror, your image will also go far from the mirror. Now, suppose we have taken these two light rays. So the light ray will go like this. Okay, these two light rays will flash, will get incident on the mirror like this. But now what happens is, this front portion that you see, only this portion is a reflected part. Means only this portion will be reflecting the light. So these two light rays cannot directly cross the mirror and come on the right hand side. What will happen? These two light rays will actually get reflected this side. They do not meet on the left side. But suppose if this is the imaginary line that you extend, they appear to meet here. So that's why whatever image you see here is actually not an actual image, it is a false image. See, these are the actual light rays. When these two actual light rays go and they are incident on the mirror will reflect the light ray. You see that there is an image formed, but actually there is no image. Okay, so that's how image is formed by using a plane mirror. This also you have studied in class 7. We are just revising it again. The image which is formed by a plane mirror is erect. The first point, look at this. It is erect. Erect means straight. If you are standing straight, you will see the object also straight. Secondly, the image is same size as that of the object, which means suppose if you are 5 feet tall, you will see the image also 5 feet tall only. The next is check this point number 3. The image is at the same distance from the mirror as the object. Is this clear? This also is clear to you? Wherever is the object from the mirror, the same distance your image will also be standing from the mirror. Okay? And the fourth point is that the image is virtual. I told you why is it virtual, because you cannot capture the image. You cannot obtain that image on a screen. Lateral inversion means from left to right and right to left. Okay?
Right to.
Yeah. So if you raise your left hand, then in the mirror what will happen?
Right hand. We'll show our right hand.
Yeah. So you can check that. This phenomena is called as lateral inversion. Okay. We are all going to meet in the next class. See you all. Okay, beta.
Thank you.
Bye.